All right, so we're going to use the distance formula to find the area of triangles and rectangles on the coordinate plane. For this example, we're going to find the area of the triangle formed by connecting the coordinates A, -4, -2, B, 1, 4, and C, 4, -2. In this example, we really don't even have to use the distance formula because these two coordinates, -4, -2, and 4, -2, are horizontal, and we can just count the units from -4 to +4 and find that our base of this triangle is 8, and the height of our triangle would be the perpendicular line coming down this way, and again, this perpendicular to a horizontal line would be a vertical line, so again we can just count these the distance for the height on this example, and the height of that would be 6, and the area of a triangle is simply 1/2 base times height, 1/2 times 8 times 6, and we get 24 square units as the area of the triangle. It gets a little more complex, however, if we don't have coordinates that are parallel to one of our axes. So let's change the C coordinate, and we're going to figure out the area of the triangle that has coordinates A, -4, -2, B, 1, 4, and C, 4, -1. In this instance, we can't just count to find the length of any one side. So what we're going to do is use the distance formula to find the distance from coordinate A to coordinate C, and the distance formula is given here. So we just plug in our coordinates, the x coordinates, 4, -4. So we're going to have the square root of 4 minus -4 all squared. And the y coordinates, -1 minus -2 all squared. And simplifying this, we get 4 minus -4 is 8. We have 8 squared. And -1 minus -2 is 1. We have 1 squared. And the distance of that bottom portion would be the square root of 65. Now we need to find the perpendicular line that passes through point B and intersects the line on which the segment AC resides. So there's several things we're going to have to do here. We're going to have to first determine what the line, or at least the slope of the line that passes through line segment AC is, because the relationship of slope of perpendicular lines is that they are multiplicative, additive inverses of one another. If the slope is A over B for one line, then the slope of a perpendicular line is m equals negative b over a. So it's the additive inverse. It went from positive to negative, and the multiplicative inverse, or reciprocal. So it's the additive inverse of the reciprocal. So you flip it and change the sign, is the way a lot of my students like to remember it. Okay, so we know that the slope of this line that passes through AC is going to be perpendicular to this, and we're going to just call this point E, just so that we have a point of reference here. And for line that passes through BE to be perpendicular to the line that passes through AC, their slope would have to be opposite reciprocals of one another. So let's go ahead and find the slope from point AC. Now we can use the slope formula, or we can just, since we already have it graphed, we can count rise over run. To get from point A to point C, we had to rise 1 and run 8. So the slope of the line that passes through AC equals 1/8. The perpendicular slope would have to be the opposite reciprocal, sorry, I think that's a E and D. Negative 8 over 1, or negative 8. So line segment BE, okay, is on a line that has a slope of negative 8. So to find the coordinates for E, we have to find both equations, the equation of the line that passes through AC and the equation of the line that passes through BE, and we have to find out where those two lines intersect. There are several methods for doing this. So let's first go ahead and find the lines. We know that for the first line, y equals 1/8 x plus b. And to find b, we need to, our b here is a lowercase b, our y-intercept. And you can use your calculator to solve this, or solving by choosing coordinates for x and y. We can plug in -2 equals 1/8 times -4 plus b. 1/8 of -4 is -1/2. Plus b. And when we add 1/2 to both sides to isolate the b, we find that -3/2 or -1.5 equals b. So the equation of our line is y equals 1/8 x plus -3/2. The line that's perpendicular has a slope of -8 and passes through the coordinate 1, 4. So finding the second line, y equals -8 x plus b. We're plugging in our coordinate 1, 4. 4 equals -8 times 1 plus b. Add 8 to both sides. We find that our b in this instance equals 12. So the equation of the line, plugging that b back into our original equation, will be y equals -8x plus 12. All right. Finally, we have to, I shouldn't say finally, because we even have steps beyond this, we have to find the coordinate where these two lines intersect. So we're going to have y equals 1/8 x plus negative 3/2 and y equals negative 8x plus 12. Now, since both of these are in y equals or slope-intercept form, if y equals this and y equals this, then the two y's will equal each other at this coordinate, of course. So these two values have to equal one another, and we can just set them equal to each other and find out what x is. So negative 8x plus 12 equals 1/8 x plus negative 3/2. Subtracting 1/8 or adding 8x to both sides to isolate the variable on one side of the equation. We have 12 equals 8 and 1/8 x, and I will change that to 65 eighths here in just a moment, just to help with the math. Add 3/2 to both sides to isolate the variable. And 12 is the same as 24/2. 24/2 plus 3/2 is 25/2. And here we have 65/8 times x. Okay, so to isolate the x, we have to divide both sides by 65/8, and the way we divide fractions is by multiplying the reciprocals. So we're going to multiply both sides by 8/65. Now, as an aside over here, I know I've got to do 25/2 times 8/65. I'm going to simplify before I multiply. 8 and 2 are both divisible by 2. 1, 4. 25 and 65 are both obviously divisible by 5. 5, 13. And 5 times 4 is 20. 1 times 13 is 13. So 20/13 equals x. Or 1 and 7/13. So the coordinate here for E, the x-coordinate, is going to be 20/13. And the y-coordinate, all we have to do is plug in 20/13 to one of our equations, and we'll find the, this equation or this equation, and we find the y-coordinate. So 20/13 times 1/8 or 20/13 times -8, whichever way you'd like to go with that. It's kind of ugly math, but sometimes situations, you get ugly numbers in real situations. So let's go ahead and try to figure this out. We have, so we're going to plug that back into our original equation for the line that passed through AC. Y equals 1/8 times 20/13 plus negative 3/2. 8 and 20 reduce. 8 is divisible by 4 and we get 2. 20 is divisible by 4 and we get 5. We have y equals 5/26 plus negative 3/2. Getting a common denominator here, I would have to multiply both of these, the numerator and denominator on this one, by 13, because 2 times 13 would give me 26. So we have 5/26 plus negative 39/26. And 5 plus negative 39 is negative 34/26. We can reduce 34/26 by dividing both of these, the numerator and denominator, are divisible by 2, so that becomes negative 17/13. So our y-coordinate is negative 17/13. Now we'd have to use this coordinate along with the b coordinate to find the height of our triangle. Keep in mind we've already found the width of our triangle, the base of our triangle as the square root of 65. So now we use that distance formula again, and this time we're going to put in the x coordinates for BE, which were 1 and 20/13. So 20/13 minus 1 all squared plus negative 17/13 minus 4 all squared. 20/13 minus 13/13 is going to be 7/13. And let's see, 4 times 13 is 52. So negative 17/13 minus 52/13 52 minus 17, negative 69/13. And square root both sides. And when we add those, we have 49 over 169 plus negative 69 squared is 4,761 over 169, and we get the square root of 4,810 over 169, and the square root of 169 is, of course, 13, and the square root of 4,810 is going to be an irrational number. So we can see if we can find some factors to simplify that. Obviously, it's divisible by 10. But then it's not divisible by 2 or 5. It may be relatively prime. We're going to go ahead and just leave it as the square root of 4,810 over 13. Again, sometimes real situations render ugly numbers. So now we have the two distances. Remember, this is our base, and this is our height. So to find the area of a triangle, it's 1/2 times the square root of 65 times the square root of 4,810 all over 13. And here's where you can type it into your calculator and find the, generally we round to the nearest tenth. If the directions could sometimes give you more instructions on that, but in this instance I think that'll suffice. We'll do these simply typing it in our calculator. 1/2 times the square root of 65 times the square root of 4,810 divided by 13. And I get the area to be 21.5 square units. All right, now this is a very long, convoluted process, and I just want to kind of review and highlight all the steps that you had to combine to get this. Of course, one, you had to know the distance formula to find the distance between two coordinates. We had to know that the relationship of slope of perpendicular lines is the opposite reciprocal, and we had to know how to solve a system of equations to find the coordinates of the point where the two lines intersected and were perpendicular to one another. We had to know how to find the equation of a line given 2 points, and we had to know how to find the equation of a line given 1 point and the slope of that line. So there are a lot of pieces from all of our algebra that we've had to tie together to complete this problem, but it's all things that you've covered in the past, and now you're having to tie them all together. Let's take one more example. This one should be a little easier to determine if a shape is a rectangle and to find the area of rectangles on the coordinate plane. In this example, we're going to determine if the polygon is formed by connecting coordinates A, -4, -2, B, 1, 4, C, 7, -1, D, 2, -7, and see if they form a rectangle. Well, what do we know about rectangles? Well, we know that opposite sides have to be parallel to one another, and we know that the angles all have to be 90-degree angles. So the intersecting sides had to be perpendicular to one another. Well, just like we discussed on the triangle just a moment ago, we can determine if they're perpendicular if their slopes are opposite reciprocals. So the slope from segment AB is going to be rise 1, 2, 3, 4, 5, 6, and run 1, 2, 3, 4, 5. Our slope is 6/5. And for this one, our slope is, we are rising -1, 2, 3, 4, 5, and running 1, 2, 3, 4, 5, 6. We're in excellent shape so far. We know that these form right angles. Now, do we know that this side is parallel to this side? Well, in order for two lines to be parallel, they have to have the same slope. So let's look at line segment CD and determine its slope. Rise 1, 2, 3, 4, 5, 6. Run 1, 2, 3, 4, 5. It indeed has a slope of 6/5, so it is parallel to AB, and is BC parallel to AD from A to D, -1, 2, 3, 4, 5, +1, 2, 3, 4, 5, 6. We have, so we have opposite sides parallel to one another. And we have 90-degree angles. So of course, this is going to be a rectangle. Now we have to use the distance formula. Well, we don't have to in this instance, but we're going to, and then we'll talk about how we could have found the area of this rectangle graphically. But let's use the distance formula first, And all we need is two perpendicular sides. If we use AB and BC, that would get us a length and a width. So the distance for segment AB would be equal to the x-coordinates, 1 minus -4, plus the y-coordinates, 4 minus -2, Five squared is 25. 6 squared is 36. 25 plus 36 is 61. Is that correct? Yes, 25. 20 and 30 is 50, plus 11, 61. Yes, square root of 61. And the distance of the other side is going to be, and this is distance from segment BC, square root of the x-coordinates, 7 minus 1. The y-coordinates, -1 minus 4. Gives us 6 squared plus -5 squared, which is 36 plus 25. And again, we have the square root of 61 is the distance of that side. So as it turns out, since these two line segments are equal, this one is a square, but the area of a rectangle is length times width. So we have the square root of 61 times the square root of 61, which gives us 61 square units for our area. Now with rectangles, often you can find the area graphically, and I want to spend a moment talking about that. If we were to form a rectangle by drawing vertical and horizontal lines through our coordinates, so looking at this rectangle that I just drawn, I probably should have done this in a different color. Let me try this here. Right. So if we were to look at this rectangle, with the diagonal being that length of the side of the original rectangle, we could find the area of the triangle that's inside that rectangle simply by finding half of the area of this rectangle. Well, this rectangle, 5 times 6 is 30, so half of that would be 15. The area of this triangle would be 15. And we would set up a similar triangle using these coordinates. Similar rectangle. And the area of the rectangle would be 5 times 6, again, 30. And half of that rectangle would be this triangle on the inside of our original rectangle, would have been 15. And we could repeat this process for each of the coordinates. And since this one was a square, all of our triangles are going to have the exact same area. And this one is the same line as that one, so it's a little sloppy here, but that one's going to be 15. And when you form this rectangle, the area of this one would be 30, and the area of the triangle, which is half of that, would be 15. And we're left with one unit here in the middle, right? So the area of the entire rectangle would have been 15 plus 15 plus 15, or 15 times 4, which is 60, plus the 1 in the middle. It would have also given us 61 square units. So it's just another way of looking at it. It's still important that you understand the distance formula and you understand whether or not the two lines are perpendicular by checking out the slope and seeing if they're reciprocals and opposites of one another. So this is how you find the area of shapes on the coordinate plane.